Hello, and today's learning target is I can multiply monomials. A monomial is a single-term expression with no adding or subtracting, just multiplying and or dividing. So you'll see, variables, numbers to a certain exponent lots of times. Some variables or numbers may not be to a certain exponent, but you will definitely see some type of exponent. So let's review some things about exponents. I see right here a b and an x. And so how I would say this is b to the power of x, b to the x, b raised to the power of x, where b is the base and x is the exponent. Okay, so if there's a small number that's being raised, that's the exponent. If there's a larger number or variable to a certain power, then that's considered the base. Consider the following monomials and write in a condensed form. So here I see 5 threes, right? 1, 2, 3, 4, 5. So how I could write this out with exponents and a base would be 3 to the 5th power. Okay, because there's 5 threes. Over here, and actually I could simplify that one step further and say 3 to the 5th power is 243, but I'm just going to leave it written as a base and an exponent. In this second example, I see x's and y's. So I'm going to count the number of x's, 1, 2, 3, 4, 5, 6, and count the number of y's, 1, 2, 3. So I get x to the 6th, y to the 3rd. And I'm not allowed to put these together and say x, y to the 9th because x and y are considered different bases. They're different variables, so I'm not allowed to put them together. Only exponents with the same base I will be allowed to combine, and we'll see that in a couple of examples. The product of powers. So multiplying two monomials with the same base means that we will really add the exponents. So if we look at this first example, 3 to the 7th times 3 squared. I'm going to write out 7 threes because 3 to the 7th. 1, 2, 3, 4, 5, 6, 7. Then I also have 2 more threes because 3 squared. 3 times 3. In total, I get 9 threes, right? So I could rewrite this as 3 to the 9th. And, 3 to the 9th is 19,683, so that would eventually simplify to that. But if we go back and look at the problem, I, in total, got 3 to the 9th, right? So what did I really do with those exponents with the same base? And the base is 3. So what did I do with the 7 and the 2? I added them. So when you're multiplying exponents with the same base, you really add the exponents. Let's take a look at the second example. 6n squared times 2n cubed. 6 times 2 is 12, and then n, 2 n's, and then 3 more n's give me 5 n's, right? N to the 5th. So what did I really do with those? I really added the powers, but then what did I do with the 6 and the 2? I still have to multiply those because that's just like multiplying, numbers. And so when I multiply, base numbers, I just multiply them. All right, the next example, 3pt squared times p to the 3rd, t to the 4th. And this first variable, p, is really p to the 1st. Even though there's nothing written by it, there's one of them there. So we'll take that into consideration when we combine them with the other similar bases. So 3 right here times, nothing, no other number over there, coefficient, so I just get 3, p to the 4th, and then, because 1 plus 3 is 4, and then t squared and t to the 4th give me t to the 6th. Okay, and then last example, I have -4 times -6 to give me positive 24. 1r here and r to the 5th give me r to the 6th. X squared and x squared give me x to the 4th. And t cubed and t to the 1st give me t to the 4th. And then that's my final answer. Now let's look at the power of a power rule. So a monomial raised to a power. So here I have c squared to the 3rd power. So what if I would write this out, I'd have 3 of these. So c squared times c squared times c squared. So 2 plus 2 plus 2 is c to the 6th. Otherwise, I could have just taken this 2 and 3 that are next to each other and multiplied them right together. And 2 times 3 is c to the 6th. So instead of writing everything out, I would have just simplified it that way. Now 2 to the third, to the second, to the fourth, this next example, if I multiply all those powers together, the first two, 2 to the third times 2, I get 2 to the sixth. Then raised to the fourth, now this 4 and 6 get multiplied together, and I get 2 to the 24th. Okay, so here I have v squared squared and get v to the fourth, all to the fourth, and get v to the 16th. Again, I multiply. And then this last one, I get 3 to the 6th times 4 to give me 3 to the 24th. And again, I could go through and simplify those and figure out, type into my calculator 2 to the 24th, 3 to the 24th, but just to save time, I'm just going to write them as a base multiplied, or excuse me, a base to an exponent. All right, now let's look at the power of a product. So here I'm going to distribute the 5 to everything inside the parentheses, so to the 2, to the x, and to the y cubed. So I have negative 2 to the 5th, x to the 5th, because 1 times 5 is 5, and y to the 15th, because 3 times 5 is 15. Negative 2 to the 5th power is negative 32, x to the 5th, y to the 15th, and that would be my final answer. This next example, I'm going to distribute the 2 to everything, both the numerator of that fraction, so if I have 4/7, it's going to go to the 4 and the 7, right? So 4 squared is 16, 7 squared is 49, and that can't simplify, so I'll leave it like that. And then m to the first times 2 is m squared. Circle my final answers. Okay, down here in this bottom one, I'm going to distribute, or I'm first going to multiply this 2 and the 3 to give us 6. Okay, so I have negative 2 xy squared all to the 6th power. So I'll distribute that and get negative 2 to the 6th power, x to the 6th, y to the 12th. And now I'll simplify. Negative 2 to the 6th is 64, x to the 6th, y to the 12th. All right, for this last example, I have to distribute the 3, so I have 1/2, it's all going to be distributed, 3 is going to go to both of those, so I'm going to get 1 cubed over 3 cubed, which is 1 over 8, and then a to the 6th, because 2 times 3 is 6, and b to the 6th as well. And that would be my final answer. Now I could rewrite that, because I don't really need to write this 1, so I could write a to the 6th, b to the 6th, all over 8. So I don't need to write that 1. I could if I wanted, so I could put that in blue, although you do not need to write that. Now let's simplify expressions and put it all together. So with this first example, I'm going to zoom in here. 3xy to the 4th is 3xy to the 4th. That's not to any power. But then here, I'm going to distribute that, or multiply those 2 and the 3 to give us 6, and I'm going to distribute the 6th. And I'm going to multiply and say negative 2 to the 6th, y to the 6th. And negative 2 to the 6th is 64. So I have 3xy to the 4th times 64y to the 6th. And 3 times 64 is 192. I have one x here, no other x's. Y to the 4th and y to the 6th give me y to the 10th. And that would be my final answer for simplifying that expression. All right, let's look at this last one. I have a lot more going on here. And distribute that 3 to everything inside the parentheses. 1 cubed is 1, 2 cubed is 8. A to the 6th, b to the 6th. Change this 2 and 3, make that a 6. Distribute the 6. So negative 4 to the 6th is 4,096. V to the 6th. 1/8 of 4,096 is 512. A to the 6th, b to the 6th and v to the 6th. And none of those variables or those bases I can combine because they're not the same. So that would be my final answer there. Thanks for listening. Have a great day. Bye-bye.